Hello everyone, I am Aaron James Anfaron, the assigned leader of Group 3 with Mr. Mendez, Mr. Operio, Miss Santos, Miss Espiritu, Miss Fernandez, and Miss Frias. We are here to explain and report about the problem-solving strategies. First, let's go with our learning objectives. Our learning objectives is to understand the importance of making a list drawing, a diagram, making a table, trying to solve a similar but simpler problem, looking for a pattern, guess and check, and indirect reasoning proof by contradiction. First, let's tackle about what is problem solving. Problem solving is the act of defining a problem, determining the cause of the problem, identifying, prioritizing, and selecting alternatives for a solution, and implementing a solution. The problem-solving process and the problem-solving resources. Now we know what is problem-solving. Let's go with what is problem-solving strategy. A problem-solving strategy is a plan used to find a solution or overcome a challenge. Each problem-solving strategy includes multiple steps to provide you with helpful guidelines on how to resolve a business problem or industry challenge. So now we know what it is. Let's go with the first problem-solving strategy, making a list. Problem-solving strategy, making a list. Strategy involves writing down all possibilities or steps. It's useful for problems where you need to consider different options or organize information systematically. For example, if you're trying to list all possible combinations of items or possible outcomes, writing them down can help you track what has been considered and what still needs attention. Let's start with the example of making a list. Putting things in order, like I said before, or to name them, like a grocery list or a wish list. Writing a review for an exam. Example, you are writing down all the possible questions and possible answers. So, that is an example of making a list. Next is the record of students list. The names of students that you are listing down is another example of making a list. Next is the time in and time out. When you are timing in, you are recording or you are listing where the students or the person come in, and when your time out is where the person out. That's another example of making a list. Let's see. My example here of making a list is the list of fruits: apple, mango, banana, grapes, strawberry. List of vegetables: potato, lettuce, squash, onion, garlic. And list of names: Aaron, Gio, Christine, Carl, and Mariel. So, cash receipt is an example of a list. So, thank you. That's all my part.
Now you know how to make a list in a problem solving. Today in my part, I would like you to know how to draw a diagram. But first, I would like you to know what is a diagram. Diagram is a simplified drawing that illustrates concept, relationship, or process in a visual format. Diagrams are widely used in fields like engineering, science, business, designs, and education. There are many types of diagrams, and each serving has a unique purpose. And I will show you some common types. The first one is the flowchart. It has a purpose to show the step in a process or workflow. It has a rectangular shape for step and diamonds for decision points, arrows to show directions of flow. It is used often in programming, process design, and decision making. The second one is the Venn diagram. It has a purpose to show the relationship between different sets or groups. It has a overlapping circles or ellipse that represents set. It is used commonly in logic, statistics, and set theory to show similarities and differences between the sets or group. The third one is the organizational chart. It has a purpose to illustrate the structures of an organizational and the relationship between its parts. It has a boxes for positions or departments, connecting with lines showing hierarchy or reporting structures. It is used common in business, corporate settings, and the team management. The fourth one is the pie chart. It's to represent proportions or percentage of a whole. It is used often in statistics, economics, and business reports. The mind map. The purpose of the mind map is to visually organize information around a central ideas. It has a central idea in the middle, with branches extending outward to represent related sub-ideas or concepts. It is used to great for brainstorming, organizing thoughts, or planning projects. The bar or column chart. It is to compare qualities or values across the different categories. It has a bars or columns where the length or height of each bar represents a quantity. It used to widely in a data visualizations and reporting. The second last is the network diagram. The network diagram is to show the components of a system and how they are connected. It has a nodes for points or entities and edge for connections between them. The last one is the ER diagram or entity relationship diagram. It has to model the data and relationship between entities in a database systems. It has or it is used common in database designs and software developments. Diagrams typically consist of the following elements. For shape, it has a different shape represent different types of data or entities. For lines or arrows, this shows connections, relationship, or flow of informations between different parts of the diagram. And for text, it has a label and annotations to provide clarity and context to the diagram. For the color, color can be used to differentiate between different elements, making the diagram easier to read. And here are some tips for effective diagrams. We should keep it simple because the goal of a diagram is to clarify, not to overwhelm. Avoid overcomplicating it with too much detail. Use consistent symbols. Make sure each shape, color, and line style has a clear consistency and meaning. Ensure readability. We use legible fonts, proper spacings, and ensures that the diagram can easily understood by the target audience. Use bold text or color to emphasize the most important parts of the diagram. Step to drawing a diagram. The first one is identify the purpose. What do you want to communicate? Are you showing a process, relationship, structures, or comparison? This will determine the type of diagram you will need. The second one is to gather the informations. What are the key elements you need to represent? Make a list of the entities, steps, or data that you need. The third one is sketch the layout. Think about how the elements are arranged. For example, in a flowchart, you'll start with a start point and work your way through the process step. The fourth one is add connections. Draw a lines, arrow, or branches to show the relationship or flow between elements. The fifth one is label the diagram. Add a descriptive text to clarify what each element represents. Use a concise, clear labels. And the last one is refine and format. Ensure the diagram is easy to read. With no clutter, make sure the flow is logical and the elements are well organized. And now we understand how to draw a diagrams. Here are my conclusions about diagrams. Diagrams are helpful pictures that can make difficult informations easier to understand, show connections, and help with explaining things. Whether you're making a flowchart, a Venn diagram, an organizational chart, or any other kind of pictures, diagrams turn hard ideas into something simple and easy to understand. Whether you're showing how something works, drawing connections, or displaying numbers, knowing how to use diagrams can make your information much easier to understand. In both work and everyday life, diagrams are very useful for making things clear, quick, and easy to understand. By learning different kinds of diagrams and how to make them well, you can explain complicated ideas quickly and clearly, which helps with making decisions, learning, and solving problems.
For these slides, I'm going to discuss the making a table strategies. Similar to making a list, making a table helps organize information in rows and columns to identify patterns, relationships, or constraints. This strategy is helpful for problems involving comparison, tracking variables, or organizing large amounts of data. So, sa paggawa ng table strategies, may mga hakbang or steps. So, the first step is understand the problem. So, I have here the example. A garden shop sells flower pots for 15 each. Determine the total cost for buying 2, 4, 6, and 8 flower pots. So, the given information, each flower pots cost 15 pesos. So, ang goal natin is to find the total cost for different quantities of flower pots. So, after you understand the problem, you need to proceed to devise a plan. The second step. We have two variables, which is the number of flower pots and total cost. So use a table to organize and calculate the cost. Step 3. Carry out the plan. Create a table or draw a table with two headings, which is the number of flower pots and the total cost. So fill in known values. Enter the quantities of flower pots 2, 4, 6, and 8. You need to calculate the values using the formula total cost equal the number of flower pots times 15. So for this table, like what I said earlier, we have two variables, which is the number of flower pots and total cost. And for step 4, look back. You need to verify the calculation and ensure all calculations are correct. And check consistency and confirm the result makes sense. So we need to look back. We need to go back in the table. For each additional flower pot, the cost increases by a fixed amount, which is 15 pesos. This means that the total cost increases linearly with the number of flower pots. And the total cost is directly proportional to the number of flower pots. For example, 2 times 15 equals 30. And it is easy to predict using the established pattern. You can easily predict the cost for any number of flower pots without additional calculation. As you can see in the table, so each number of flower pots is adding 15 pesos per 1 pot. So for calculation of the total cost, we have 300 pesos. So notice that for each increases of 2 flower pots, the total cost increased by 30. Since 15 per pot times 2 equals to 30. These patterns hold true consistently across the table, showing a clear linear progression. So katulad ng sinabi ko, nakuha na natin yung total cost, which is 300 pesos. So sa paggawa ng table, mas pinapadali nito mag-calculate or magkakuha ng tally sa mga problem. Katulad ng ginawa natin. Sana naintindihan nyo. Salamat.
Problem solving, trying to solve a similar but simpler problem. Problem solving strategy, trying to solve a similar but simpler problem. When faced with a complex problem, you make first attempt a simpler version of. If solving a smaller or related problem can provide insight into the large problem or help identify patterns and approach that are the transferable. Identify the complex problem. You're facing a challenge that seems overwhelming and might have a lot of parts, confusing details, or involve many different factors. Find a simpler related problem. Imagine a similar problem but one that's less complex. It should share some key figures with the original problem, but be raised to understand and the tackle think of it as a smaller, more manageable version of the sum puzzle. Solve the simpler problem. Use your problem-solving skills to find this simpler version. This may involve using other strategies like making a list, drawing a diagram, or working through it by step. Applying the solution to the complex problem. Now that you've solved the simpler problem, see if you can apply the same logic, principles, or techniques to the original, more complex problem. The solution to the simpler problem might give you valuable insight or point you in the right direction for tackling the large issue. Example, let's say you have trying to plan a big family reunion that's a complex with many details to consider. Dates, locations, activities, food, etc. Simpler problem and instead of planning the entire reunion, you could focus on planning a smaller, simpler gathering for a few family members, maybe a weekend dinner party or a day trip. A solution to simpler problem is you may decide to send out invitation, create a menu, and delegate some stocks to family members. Applying the complex problem is now you can adapt those strategies to the largest reunion. You can create a checklist, delegate rules to different family members, and even use the smaller gathering as a test run to try out different ideas. Thank you.
In this tutorial video, we're going to look at the problem-solving strategy of looking for a pattern. Problem-solving, looking for a pattern. Identifying patterns can simplify complex problems, whether you're working with numbers, shapes, or sequences. Spotting trends or repetitions allows you to generalize and apply solutions more efficiently. This method is especially useful in algebra, number theory, or puzzles. To find the patterns, we have 4 techniques. So first thing you need to do is find out what is the question. Come up with a plan. We're going to use a strategy of looking for a pattern. When to go ahead and solve the problem, carry out your plan. And always verify or check your work, make sure your answer makes sense, and that you're actually answered the question. Now, let's take a look at an example. So, first week of chess club had 3 students, and second week had 5 students, the third week had 8 students, and the fourth week had 12. If this pattern continues, how many students will show up for the 8th week? Well, what are we being asked? How many students? How many students will show up for the 8th week? So, we're actually going to use 2 strategies in a way here, because I'm going to make a table and we're going to figure out how many students came that 8 weeks. So una, gumawa kayo ng table gaya ng ginawa ko or gaya ng nakikita nyo. So dito sa taas ang week. At dito naman sa baba yung hinahanap which is students. Simulan na natin. So the first week of the chess club had 3 students. So first and 3 students. The second week had 5 students. The second week had 5 students. The third week had 8 students. Third week and 8 students. And the fourth week had 12. 4 and 12. Okay. If this pattern continues, how many students will show up for the 8th week? So ngayon, sisimulan natin para mahanap natin ang pattern at kung ano nga ba ang tamang sagot o kung ilang estudyante nga ba how many students will show up for 8th week. So now 8th week. So meron na tayo ditong 4 na week. So lalagyan lang natin ng 5, 6 week, 7 week, and 8 week. Now, kailangan natin malaman ang pattern para malaman natin kung ano nga ba o ilang estudyante ang nagpakita sa 8th week, sa 5, 6, 7, and 8th week. Now, let's do that. Para madali, ganito lang ang gawin nyo guys. So parang ganito, ipa-plus nyo lang itong 2 plus 3 is equals 5. Diba? Ganyan lang. So, next, 3 plus 5 is equals 8. So 4 plus 8 is equals 12. Next, 5 plus 12 is equals 17. So may 17 na estudyante sa 5 week. 6 plus 17 is equals 23. So may 23 student na. 7 plus 23 is equals to 30. So may 30 student na. May 30 student na sa 7 week. 8 plus 30 is equals to 38. So ngayon, nahanap na natin ang pattern. Kung paano ko nga ba nakuha tong 38 students. Madali lang yan. So parang pina-plus nyo lang yung nasa taas sa baba. Kung paano ko tinuro. So yun, nahanap na natin kung ilang estudyante nga ba, kung how many students will show up for 8 weeks. So ang nagpakita is 38. So ang answer is 38 students. So now let's double check our work. So we got 8 weeks. Okay, looks good. So you probably should reread the problem and just make sure you plug in the correct information. For the first week had 3 students. The second week had 5 students. Okay na. So third week had 8 students. 4, 12, 5, 17 students, 6, 23 students, 7, 30 students, 8, 38 students. Everything looks good. So the answer makes sense. The answer is 38. So the answer is 38 students. And that's how you can use a table and look for a pattern and solving a problem. So now let's go to example 2. A florist puts 2 flowers in a vase on Monday, 4 flowers on Tuesday, 6 flowers on Wednesday, and 8 flowers on Thursday. If this pattern continues, how many flowers will he put into a vase on Friday? Now, let's find for a pattern. So here's the pattern so far. 2, 4, 6, and 8. So, Monday, Tuesday, Wednesday, and Thursday. So, if this pattern continues, how many flowers will he put into a vase on Friday? So, kailangan nating mahanap kung ang pattern, kung ilang flowers ang nilagay niya sa vase on Friday. So each day, the florist add two more flowers to the vase than he added the day before. So the pattern is counting by 2. So 2 plus 2, 2 plus 2 gave the flourish 4. 4 plus 2 gave the flourish 6. 6 plus 2 gave the flourish 8. Ibig sabihin, we need to add 2 to 8 to give us 10. So, 8 plus 2 gave flourish 10. So now, nahanap na natin ang answer, which is 10. So the pattern is 2, 4, 6, 8, and 10. And the answer is 10 flowers. 10 flowers. 10 flowers on Friday.
The guess and check method refers to a basic problem-solving strategy where you propose a potential solution to a mathematical problem, evaluate it to see if it fits the given conditions, and then refine your guess based on the outcome. This approach is commonly used when a problem does not have a direct formula or when exploring patterns, relationships, or approximate solutions. Example, finding the weight of a bag. You have a bag of apples but you don't know its weight. You know the total weight must be around 15 kilograms. Number 1, guess. You estimate the bag weighs 10 kilograms. Number 2, check. You weigh the bag and find it's actually 18 kilograms. Adjust guess, you try it again and get 17 kilograms, and then you check again and you see that the weight of the bag is closer to 15.5 kilograms. And the final adjustment is you guess 15 kilograms and it matches the correct weight. Another example is baking without a recipe. Imagine you're trying to bake cookies without a recipe. You know the general ingredients, which is flour, sugar, butter, eggs, and etc. But not the exact proportions. Number 1, you start by guessing. You start by guessing the proportions, which is 2 cups of flour, 1 cup of sugar, and half a cup of butter, and 1 egg. You check the ingredients and bake the cookies and find that they are too dry, and then you refine the ingredients by just adding more butter and another egg.
Now, let's talk about inductive reasoning. Ano nga ba ang inductive reasoning? Inductive reasoning, or known as indirect proof, is a proof by a contradiction. It is a method of proving a theory by assuming the opposite of the theory and then showing that the assumption leads to a contradiction. So, when we say contradiction, a contradiction is a combination of statements, ideas, or features of a situation that are opposed to one another. For example, Elizabeth's baby is crying. She knows that there's a clear reason why her baby is crying. So, nagbigay daw siya ng sitwasyon, 3 sitwasyon kung bakit umiiyak yung baby ni Elizabeth. The first statement, maybe the baby is hungry. The second one, the baby is in pain. The third one, the baby have food. So, dun sa statement na yon, base sa kanyang observation, when she gave a baby a breast milk, the baby didn't stop her crying. When she tapped the baby's body, the baby's cry aloud. But when she holds the baby's diaper, she smells something. She thinks that she thinks why the baby is crying because he or she is uncomfortable. So what's the reason why the baby is crying? The baby have food. Dito kasi sa inductive reasoning or indirect proof, parang nagbibigay ka lang ng ideas or assumption sa isang phenomena or pangyayari without any proof. Parang nagbibigay ka lang ng assumption. So, parang dito sa unang binigay na example, parang siyang nagbigay lang ng guess or assumption base sa sitwasyon kung saan yung tatlong assumption ay naroon lang dahilan kung bakit nangyari ang bagay na yun. Kung bakit umiyak yung baby ni Elizabeth. Parang hindi ba't sa detective na kapag wala pa silang na ibibigay or wala pa silang sapat na proof dahil nangyari yung bagay na yon, parang nagbigay lang sila ng isang assumption kung bakit nangyari ang mga bagay na yon. So, let me give another example para hindi nakakaito. Second example. We have here 4 numbers. The 2, 4, 16, and the 256. And then question mark. So, what's the next? Anong sunod dyan? When you observe the numbers, anong unang pumasok sa isip mo? Maybe, sabihin na natin, multiply. Yes, multiply. Multiply by 2. Bakit 2 times 2 is equals to 4? Yes. But 4 times 2 is equals to 16 ba? No. Kasi 4 times 2 is equals to 8. Masyadong malaki yung next number para i-multiply siya sa 2. So, kung i-observe natin, parang multiply by itself. So, 2 times 2 is equals to 4. 4 times 4 is equals to 16. And 16 times 16 is equals to 256. So, sabihin na natin multiply by itself. 256 times 256 is equals to 65,536. So the conjecture, the next number of 256 is 65,536 because it multiplied by itself. That's all. Thank you.